Okay, thanks, Isaac. Okay, now I hope all are well. If you have anything, any problem, you could not attend the class, please just WhatsApp me, message me. I'm fine with it. All right. Okay. The last time, we stopped is I asked you to try out this hydraulic jump activity, right? Okay. Let me share the slide. Okay. I'm just going to go through, the answer. I think this would be very easy for you. All right, to answer this. I hope all of you have tried this out. Okay. Just to find the conjugate depths. Okay, Y2 would be 4.866 meter. Again, for hydraulic jump, of course, the depth, all right, before the jump is in supercritical condition. So the fruit number should be greater than 1 lah. Okay, that is how you check it. All right, so and Y2 is larger than Y1. Okay, wait, somebody. Okay. All right. Okay, it's a steady jump, and then the energy loss is 53.99%. You can check, yeah? I just go through it. All right. I'll share this once at the end of the chapter. I'll share all this with you. Okay. What I want to explain next would be this activity, which is 4.5. Anyone have tried this out? Any of you dah cuba aktiviti 4.5 ni? Ada yang dah cuba tak? Tak ada
Belum Dr. ini. Belum Dr. belum.
Belum, okay. Okay. Belum, okay. Untuk selesaikan soalan ni, okay, dia sebenarnya bagi dua parameter je, which is the upstream fruit number, which is given as 12. Alright, so 12, you kind of know what jump it is already, right? Okay. Then is strong jump lah. Then you have energy loss 4.2. It's a rectangular channel, so you can write out, the formula. You could use the conjugate depth equation and also the energy loss equation. So write it out, then you can solve for sequence depth. But you have to solve this, you have to substitute the conjugate depth equation into the energy loss equation. Then you can solve for sequence depth lah. Okay, this is how we do it lah, basically. You write out, your conjugate depth equation in terms of Y2, then you substitute Y2 into the energy loss equation, then you can solve for it lah. Okay, since you haven't tried it, I want you to try it out lah. If you want to ask the answer from me, you can always text me, or just text it in the group. I'll give you the answer in the group. Then everyone can get the answer, right? But not the the workout of the question, but only the solution. I'm going to share it, right? Now, today we are going to look at gradually varied flow. So hydraulic jump is an example of rapidly varied flow. So this one is gradually varied flow. That means if you look at the definition, right, the depth of flow changes gradually, right, along the distance. Okay. Now, just a second, I want to check why it's so noisy out there. Okay. Now, where can you see, cases where gradually varied flow occurs? For example, you have drawdown, right? When the flow is flowing on a mild slope, then the slope changes from mild to steep slope. Therefore, you have, the flow changes, the depth of flow changes gradually. All right. Of course, this is not like, like very steep slope, right? So if very steep slope, then you have, very fast flow as well, right? Now, since we are looking at this, this figure here, notice that I have M2, I have S2. All right. Look at this. Y not greater than YC, I have mild slope. Okay, that means it's when y naught is greater than yc, by now you should know this is in subcritical state. Alright, because y naught besar daripada yc kan, jadi aliran dia adalah lebih perlahan, jadi dia ialah dalam keadaan subcritical. Now, satu lagi klasifikasi berdasarkan y naught dan yc ialah bila kita nak kelaskan cerun dia, which is the slope. Alright. When y not greater than yc, it is mild slope. Therefore, the 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 word m, all right, the letter m denotes mild. So we are using the symbol m2. All right. Now I'll explain later why too. Okay. Then look at this. The depth. All right. This is actually going to why not? This is why not? And YC remain the same because the width of the channel is the same, discharge is the same, so you'll get the same YC. So the dashed line here is denotes the depth of YC. The dashed dot is the depth of uniform flow. Now, if the depth of uniform flow is less than YC, this flow is in supercritical flow. Or, okay, you can also, when it asks about the classification of slope, it is in steep slope. On steep slope, the flow is on steep slope. Therefore, all right, the notation of S. All right, S2. Now, why 2? I'm going to explain now. If Y naught is greater than YC and the depth of flow, all right, is actually okay, it's actually greater, this is between, okay, here is Y naught, this is YC. If the depth, if you have a backwater flow, which will increase the Y naught, okay, increase the Y naught, that means greater than Y naught. I'm going to use another symbol, which is Y. Now, Y would be instantaneous depth of flow. That means at any time, it'll either increase or reduce. For example, here you have Y naught here, which is denoted by dash dot line, right? Now, for this slope for this slope. And then for another slope, if you are using Manning or Chasey, right? Because it's the depth of uniform flow actually is is influenced by the slope of the channel. So you are going to get another depth of flow. Jadi, kalau tengok sini kan, selain daripada Y naught yang ukur dalam yang dash dot ni kan, yang ukur dalam yang berubah ni, okay, dia ialah saya akan namakan dia sebagai Y. Maknanya ukur dalam aliran pada bila-bila masa. That's why I say it's instantaneous depth of flow. Kalaulah Y ni lebih tinggi daripada Y naught, lebih tinggi daripada YC, dia dalam zon 1. Kalaulah ukur dalam, tengok ukur dalam yang garisan biru ni, dia berada antara zon Y naught dan YC, jadi dia ialah zon 2. Kalaulah Y naught ni jatuh dekat zon, maknanya dia ukur dalamnya kurang daripada Y0 dan kurang daripada YC, dia ialah zon 3. Therefore, is M3. Now, M, sekali lagi nak tentukan sama ada MS, iaitu jenis cerun the type of slope is you compare Y0 and YC. Once you establish whether it's MS or H or A adverse, alright, or C critical, dah dapat jenis cerun, kita tentukan pula ukur dalam aliran pada bila-bila masa tu berada di zon mana, zon 1, 2 atau 3. Sama juga sini, okay, you dah tentukan dia ialah steep slope, iaitu sebab Y0 dia kurang daripada YC kan, S. Tapi aliran ni dekat zon mana? Dia ialah zon 2. Kalau ada aliran dekat zon 1 ni, ini ialah S1. Kalau ada aliran di zon 3 ni ialah S3. Maknanya ni aliran ni maksudnya ukur dalam lah. Alright. Setakat ni ada soalan tak? Nanti saya akan ada jadual dia lagi kita akan go through. Okay. Kalau tak ada soalan saya teruskan Alright. Now, you can also see gradually varied flow profile when you have backwater. Alright. Sebab biasanya aliran akan mengalir, lepas tu bila lake ni dah penuh, dia akan sebabkan aliran balik. Okay, aliran balik nanti kat sini dia akan increase lah. Ukur dalam ni akan increase slowly kan. Sebab tu dia sebabnya kalau tak ada gangguan, no disturbance right downstream kan, you akan dapat Y0. Tapi kalau you tengok bila drop back water ni, normally will increase the depth of flow lah, alright, upstream. Okay. Okay, nanti kita datang balik lah sini, don't worry. Okay. Okay, type of slope. Now, for you to establish the type of slope, of course, one is you look at the comparison between Y0 and YC. The other one is you look at the slope. You compare with S0 with SC. S0 is the, the slope of the channel lah. SC, I think you by now you should know how you get to SC formula already. Remember you compare, you actually solve for S not equal to SC. What I mean is you are equaling the Manning formula with the critical flow formula. So you'll get formula of SC lah basically. Okay, kita dah belajar macam mana dapatkan formula SC ni. Now, kita fokus dulu for the first at the first column Now, kalau Y0 lebih besar daripada YC, it is subcritical flow or it's on mild slope. So the symbol is M. Okay. If Y0 is less than YC, it is supercritical flow or is on steep slope. Okay, I hope you are clear. If Y0 equal to YC, okay, there are cases where Y0 equal to YC. That means if I go back here, alright, Y0 is this has the same depth as YC, alright. But of course, it's rare, very rare. Or it's well, at sometimes right, it will occur, especially at control section lah, alright. Y0 equal to YC is on critical slope. Therefore, the symbol is C. Alright. Now, imagine you have water in a horizontal channel. You actually, if you didn't have force, you didn't put force on it, the flow would not occur again. So actually, there's no uniform flow. Therefore, if you look at this, let's put it here. If you try to solve for Manning equation, all right? Remember, this is I'm rewriting the Manning equation in terms of section factor again. Kalau lah S not to kosong, because when you have horizontal, Your S naught is 0 kan? Alright, S naught is 0 because it's horizontal. Can you solve for Y naught? No, you won't get Y naught. Okay, so it's a horizontal. Okay, which is denoted by H lah. Okay, so remember S naught when it's 0, you are not supposed to have flow lah, due to gravity. Unless unless you include any disturbance or force into the flow, then it will occur. Okay, now the fifth type of slope is adverse. Flow is caused due to gravitational force. Is flowing from higher ground to lower ground. In adverse condition is in inverse. That means it's flowing from lower to higher ground. Sometimes it's due to backwater flow, all right, or there's another force lah, all right, that cause it to flow. Therefore, look at this. The slope of the channel is negative. All right, because normally, in flow in open channel, slope from higher ground to lower ground is positive. When it's adverse, it's negative slope. Okay, so if you try to solve it, you can't get Y naught as well. Okay, because negative to the power of half, you can't solve it, right? So you won't get Y naught lah as well, right? All right. Hope you are clear with all this classification of slope. This is important because we would sometimes ask you to classify type of gradually varied flow. So you need to know. But typically, right, these two will typically occur lah. All right. This is very rare. Okay. But it does occur. All right. Now, since you have already know, okay, what is M? M is, look at this, Y not greater than YC, Y not greater than YC, Y not greater than YC. Now, what is Y? Y is the depth of flow, which is not Y naught and which is not YC, is the instantaneous depth of flow. That means it's the depth of gradually varied flow. If the depth is greater, I think this is what I've explained earlier. Greater than Y naught and YC is in zone 1. If it's between, zone 2. If it's less than Y naught and YC, zone 3. Okay. Same thing as steep slope. Okay. If you look at this, I'm arranging in order of which is greater. Okay. If Y is greater than, of course, steep slope is when YC is greater than Y naught. Okay. Or Y naught less than YC lah. Alright. So I'm arranging Y. Okay. I'm arranging all the depths in terms of, descending order. Alright. So if Y is greater than YC and Y naught is zone 1, between zone 2, and if it's less than both Y naught and YC is zone 3. So same thing here, critical slope. Now since Y not equal to YC, you only have two zones, which is 1 and 3. So C1, C3, you won't have the third zone because Y naught is equal to YC, right? Okay. Now, for horizontal, same thing. Horizontal and adverse are the same thing because you can't find Y. There's no Y naught. There's no Y naught, so it's either Y greater than YC or less than YC. Same thing here. So you have H2, H3, A2, and A3. Okay. So this is how we classify lah gradually varied flow. Okay, next we'll see. This is just to show, all right, the longitudinal section of the flow, all right, to visualize how M1, M2, M3 would be lah. Okay, it's actually repeating the previous slide lah. It's just that the previous slide is all the the criteria. Okay, so you have mild slope. Okay, if you look at this is a gradually varied flow profile that will be produced. Okay, this one as well. All right, but it's depending on the depth of the flow profile produced. Okay, then you are going to have which classification it would be. All right. This is normally, due to, flow drying out. So you are going to have this case. Okay. Then you have steep profile, uh, flow profile on steep slope. Okay. Then you have flow profile on the critical slope. All right. Horizontal and adverse. Okay. Now, all curves in region 1 have positive slope and region 2 have negative slope lah. All right. If you look at this, it's ascending down lah. All right. It's draw down curves. Okay. This is actually repeating lah. Okay. NDL stands for normal depth line. Is also we have already established in our class saying that we could use either depth of normal flow or depth of uniform flow interchangeably. All right, you can use either one lah, normal depth or uniform depth of flow. So this is normal depth of flow. CDL stands for critical depth of line. Critical depth line. All right. Okay. This is horizontal asymptote. Okay, it's going to have horizontal lah basically. All right. All right. This is approaching horizontal. Okay. All right. Now, there are actually this few slides shows a lot of examples where this gradually varied flow will occur. Okay, due to obstruction of weir dam. All right, it obstruct it. Therefore, initially, right, if there's no obstruction, right, if there's no this structure here, the flow will just flow in terms of in the condition of uniform flow. However, if you put an obstruction, right, water will pile up. Then once it overflow, of course, there will be backup lah, right, of flow. Then this part here is gradually varied flow. And this is why, if I ask you to classify this, okay, maybe I'll ask somebody, maybe Teva, are you there? Teva?
Yes, sir. There.
Hey, what is this classification, Can you tell me? The depth of the flow, the gradually varied flow there, what classification it is? Look at this. Y not greater
Uh,
than YC is what? Slope.
it,
Huh?
I think as the YO is greater, right?
Yeah. There?
Yeah, I don't have the table. And it's
Okay.
M,
It's mild slope, Okay.
mile
Now.
slope, mile slope.
Then what zone it is? 1, 2, or 3 here?
I think three.
Why 3? It's great.
Two. I'm sorry, two.
Why 2?
Two, right?
This depth
That's
is
not two.
greater than Y not and greater than YC. So it should be 1. If you have
Oh,
depth
okay,
in
okay.
between, it should be in zone 2. All right. This is zone 3. I hope you are clear. All right. Thank you, Deva. Okay.
Welcome, doctor.
There and 1. Okay. Okay. Your notes should have it already. Okay.
Yeah, I
Okay. The
haven't
next.
downloaded it. I'm sorry, doctor.
Oh, okay. It's fine. Aizat, are you there? Aizat. Oh, it's okay. I think because when I switch on full screen, I cannot see the names already. Okay. All right then. It's fine. Auni, are you there, Auni? Auni?
Yes, doctor.
Auni. Help me identify the type of profile for this
Doctor,
one.
can I ask
Huh?
something first?
First,
Yeah, may
what's
I know where is the Y depth, because I don't, because I pening mana satu dia punya Y.
ni? Ni semua depth ni.
Even though yang bawah tu pun I mean dia punya Y tu tak sama pun, sama juga Y.
Macam mana? Dia macam ni tau. Aliran asalnya kalau tak ada, contohnya kat sini kan dia jatuh bebas ataupun ada satu depression ataupun takungan lah kat sini kan. So asalnya kalau lah tak ada takungan, aliran dia kan normal kan, dia Y not kan. Lepas tu kita boleh dapatkan YC jugalah. Betul tak ni? Kemudian now disebabkan ada takungan di downstream, di hilir, alright, kita akan dapat satu profil aliran beransur, which is the gradually varied flow profile. Betul tak? Ni.
Betul, betul.
Okay. So ini ukur dalamnya. Iaitu ukur dalam aliran iaitu profil aliran beransur ni. Kita nak tentukan klasifikasi aliran ni. Ukur dalam ni lah.
Oh,
Maknanya
okay.
tak
Dia
kisahlah
Y
mana-mana
kan?
titik, tapi profil ni. Profil ni lah yang GVF ni. Kan?
Oh,
Betul tak?
yeah.
So sekarang dah clear
Dah. So
Okay,
dia
thank you.
dalam mind slope lah kan, doktor?
Ya betul.
Okay.
Jadi sekarang ni, kalaulah saya bandingkan Y0 dengan YC, dia slope apa?
Mind slope.
Kenapa?
Sebab YO lagi besar daripada YC.
Okay, alright, betul. Okay. Jadi dia M. Lepas tu, apa klasifikasi aliran ni, aliran GVF ni? Pada mana-mana titik lah. Dia zone
2.
berapa? Zone 2. Kenapa?
Sebab dia dekat tengah-tengah dekat
Yeah, betul. So, you see saya letak Y sahaja sebab actually Y ni M2 Y ni, okay, kalau saya tanya ukur dalam Y ni berapa kan, saya sebenarnya boleh cakap Y ni ialah ukur dalamnya daripada Y0 berkurang hingga menghampiri YC. So kadang-kadang mungkin akan ada soalan kan, dia akan tanya berapa ukur dalam ukur dalam Y ni. So you kata sebenarnya Y ni ialah kurang daripada Y0 dan menghampiri YC lah. Sebabnya kan nanti in subsequent slides, right, we actually have to analyse berapa jauh aliran ni dan juga ukur dalam ni. Kita sebenarnya boleh lukis profil ni nanti. Selepas topik ni lah. Ya saya.
Doktor.
Yes.
Actually kan, yang kiranya the Y, the depth is bukan tengok yang last, dia tengok daripada yang after YC, tengok cara dia berkurang
Kita tengok keseluruhan ni sebab apa yang
Okay.
kita belajar ni sekarang ni ialah gradually varied flow profile. So aliran berubah beransur kan. So dia berubah beransur-ansur. So profil semua ni lah.
Oh,
So
okay,
it means the
betul,
Y
baru
is
faham.
decreasing. Is it?
Yes. Right now it's decreasing, correct.
Okay.
Okay, so
Sometimes
faham.
the
So
profile
YO,
increase.
okay. So
Okay,
it's M2 lah. Okay.
Alright. Okay, kita dah no longer, mungkin sebelum ni duk cari Y0, YC kan, sebab sebelum ni kita hanya, kita kata kita belajar uniform flow kan. Of course kat mana-mana titik pun Y0 sama je kan, betul tak? Okay. Alright. Okay. Now. Alright. Kalaulah, okay. Assuming saya tak tahulah dalam nota ni dia bagi tak. Saya nak cari profil ni dengan profil ni. Siapa nak volunteer? Sebelum saya panggil nama. Saya should print out my list. Siapa nak volunteer untuk bagi saya jawapan sini? Kalau based on why not dengan YC ni lah. Farah ada? Farah ada tak? Kalau Farah tak ada. Mafira ada? Ha?
Is it M1, Doctor?
M1. M1, betul M1. Okay, sebab dia M sebab Y not greater than YC kan? So
Yes.
M1. This one?
M1 juga.
Betul, M1 juga. Yang ini?
M3.
Yes, correct. Thank you. Okay, semua pass. Okay. Alright. Okay, yang ini? Yang ini dulu.
S1.
Correct. Ini?
S3.
Betul. Okay. Oh, you all tengok saja Okay. Alright. S1, S3 Okay. Saya nak if just using this alright, actually you cannot. This here is different, but I just wanted to ask about this profile and this profile. Sebenarnya kat sini tak boleh lah. Mungkin part ni sajalah. Yang ni profile apa? Yang ni profile apa? Boleh bagi tahu?
S1 dengan S2.
Betul. Thank you S1 dengan S2. Okay, harap semua setuju Okay. Alright. Kalau rasa nak argue dengan saya, bagi tahu dulu. Okay, yang ini?
S3.
This one S3. Betul? This one? This one apa?
S3.
This one? Semua S3 kan? Okay. Cuma dia punya why not dia berubah sebab slope dia berbeza. Sebab kita nak cari ukur dalam aliran normal. YC tak berubah sebab YC formula dia tak bergantung pada slope tau. But for Manning, alright, Manning actually it depends on the slope lah 2/3, alright. So if the slope changes, your Y not changes. That's why you have different depth lah. Okay. Alright. Okay. I want this. I want this. Who can give me?
H3 dengan H2.
Yeah, thank you. Alright. Thank you. No H1, right? Okay. Alright. This one. This one is apa ni? Ada dua saja kan, iaitu
For this, where is the Y, Doctor? I don't get
there's
it.
no Y, right? There's no Y not, right? Only YC kan, adverse.
So Y? The Y?
Huh?
The
But
Y.
you cannot find Y not kan for adverse slope.
Yes.
So
Is it
you only
sebab dia
compare it with
infinity,
YC.
Doktor?
Huh?
Sebab dia infinity kan, Doktor?
Ya, betul-betul. Tak ada. You tak akan dapat uniform flow. Sebab kalau lah kan aliran open channel ni mengalir disebabkan oleh aliran graviti. Ini disebabkan you ada pressure kat sini baru dia force aliran ni berlaku tau. Jadi Y not you takkan jumpa. Sebab kalau you gantikan dalam chasing and Manning you takkan dapat Y not. Sebab S dia negatif kan. S not dia negatif kan. So kalau ini A apa? Apa dia punya type of profile?
A3 dengan A2.
A3 dengan A2.
3-2 okay. Alright, A3 and A2 okay. How about this one? I think this you have this one and this one. Terus je lah bagi saya apa? Kalau tengok sini.
S1.
Yes? This one?
S3.
Okay, thank you. Same thing lah Here also. Is it same thing?
M1, M3.
Correct. It's M1, M3, Alright, because you have these are different. Okay, these are different. Okay, these are the answer for earlier activity. Now let's look at activity 4.7. We have a rectangular channel, okay, with bottom width 4 meter, bottom slope 8 to the power of 8 times 10 to the power of minus 4. Discharge Q 1.5 Q max. Now, along a gradually vary flow in the channel, the depth at a section is found to be 0.3 meter. Okay. That means I don't know. I don't know how this would look like. Okay, I don't know because it has a slope, right? I'm going to sketch it here. It has a slope. I don't know how it would look like. Okay, but it says gradually vary flow. Okay, but I don't know what is the Y naught. I don't know what is the YC, but it says it has a gradually vary profile. Okay, at one section the depth is 0.3 meter. That means okay, I'll go back slightly. Okay, I don't know what is the type. All right. Let's discard this, clean this up. Okay. Let's just use one example. Okay, let's just use this. I don't know what the type is, but it says at a point, it just say at a location, the depth is 0.3. Okay, meter. It doesn't, because it doesn't want to give you the range, right? It'll just give you one depth. All right. So let's go back. All right. Okay. Assuming Manning N is 0.06, 0.016, all right. Find the type of gradually vary flow profile. Now, here's the thing. You want to determine the type of gradually vary flow profile like we have done earlier, all right? We need to know Y naught and YC first. Okay, that means we need to find Y naught, we need to find YC. Then we are going to compare this. This is Y. We are going to compare this Y with Y naught and YC to get the zone. By comparing Y naught and YC, we know the type of slope. Then compare it with Y, we can get the zone. So we can establish what it is. So the step would be, here either one, you can find YC first or Y naught, it doesn't matter. So if you look at here, saya cari Y naught dulu lah. Alright, Y naught, dah dapat Y naught. Then I find YC. You can use the formula, this one also, it doesn't matter. All right. But anyhow, you also have to, have Q divided by B lah to get discharge over unit width, right? Okay. So, because it's rectangular, so therefore I can use this formula, right? So, dah dapat YC. Okay. So, saya tengok Y naught dengan YC. Saya compare. Alright. Y naught and YC. Alright. Y naught greater than YC, jadi dia M. Lepas tu Y saya ialah 0.3, iaitu berada di antara Y naught dan YC. Jadi zone 2. So it is M2. I hope you are clear. You can try this out later. Hope you try it out. Alright. Activity 4.8 is similar to earlier one, except that of course you want to use solve for Y naught. We have learned this in chapter 2. You want to solve for this, okay? You need to find to solve for section factor, right? To find Y naught. All right, so you have to key in lah in your calculator. Let me tell you this, for triangular section, if you want to solve for Y naught, right, using section factor, right, you can actually solve directly. I don't think so. You need to go through try and error lah. Okay, you can actually solve it directly. Okay, but this is rectangular, so it's different. Same thing, you find your YC, compare it, we'll get S3. So we have Y0 0.2293, YC 0.35. So I'm going to arrange all this. Okay, I have Y 0.186. I have Y0 0.224. I'll just put 0.224. I have YC equals to 0.35. So if I'm going to arrange it in a descending order, that means I'll put YC first, Y0 and Y. So it'll give me S3. Okay. Saya susun mengikut nilai berkurangan lah. Maknanya saya akan susun YC dulu paling tinggi, and then berkurangan Y0 dan Y. Jadi saya akan dapat ini S, lepas tu ini zone 3. Itulah S3. Now this is triangular channel. Okay. Saya sebenarnya saya go through sebab saya dah bagi nota yang ada contoh latihan ni lah. So those you probably don't want to look at the solution. Try this out at home, alright? Check whether you can do it yourself or not. Okay. Just now I mentioned that for triangular channel, right, you can solve this directly. In fact, okay. You see, you can actually, this is only in terms of why not, okay? You can actually simplify this into, this one. So you can solve directly. Maknanya, why not ialah 0.1897 kuasa 3/8. Sebab kalau both side kuasa 3/8, yang ni you akan jadikan di satu lah, alright? So why not 0.5361? You don't really have to, tapi kalau nak solve guna calculator pun is okay lah. You have your calculator, right? Okay. Right. But this is very direct, tak perlu pun try and error lah basically. So, now tengok ni. Saya tak guna formula YC sama dengan Q kuasa 2 per G kuasa 1 per 3 tau. But instead, I'm using this formula. Why? Because it's a triangular channel. It's not a rectangular channel. So I'm solving for YC. Okay. So I have Y0 equal greater than YC. It is mild slope. Ini soalan untuk jawab type of slope. Okay. Kemudian, the second part. Tanya, what is the limit of depth of flow in region 1, 2 and 3? Okay, now I have Y0, I have YC, and I have the channel's bottom. So this is YC, this is Y0, okay? Now, for region 1, since this is mild slope, right? Betul tak kalau saya cakap untuk dapatkan M1, okay, ukur dalam dia mestilah lebih besar daripada Y0. Setuju tak semua?
Setuju.
Okay. Untuk dapatkan M2, betul tak kalau saya cakap ukur dalam dia, limit dia mestilah kurang daripada Y0 dan lebih besar daripada YC? Betul kan? Betul semua?
Betul.
Betul. Untuk dapatkan M3, the depth should be less than YC. Agree Kan? Betul kan?
Agree.
Okay, thank you. Alright. Ada pun orang. Thank you so much guys. Alright. So, itu jawapan kita. Dia kata give the limit. So, you give the range. Okay. So, for M1, it should be greater, the depth Y should be greater than Y0. So, and then M2, it should be between YC and Y0. Meanwhile, for M3, the depth of flow should be less than YC lah. Alright. That's the answer lah. Okay. So, this is the one. Okay. Alright. That's how you do it, Okay. analysis of gradually varied flow profile. Wait, let me check what time is it. Okay, it's already 1 hour. I know if I go through the slide, you don't really, you can't really, like half of you cannot focus too much on it. But I'm going to go through some slide, then we'll do the analysis on Sunday. But I want you to, you go back, whoever whoever, have not download the slide, please do so. You go through. Actually, you know, when I was, kalau saya baca satu buku kan, saya baca kali pertama saya faham mungkin berapa persen. Baca kali kedua benda yang sama saya akan faham lebih banyak. Baca kali ketiga lagi banyak saya faham. Jadi, I hope that before you enter my class, right, you have gone through you have do some reading. Then when I explain it, you also have question to ask, right? You can understand further. All right? Okay. Now, analysis of gradually varied flow profile. So this will be our last topic lah, the analysis. But under this topic, we have a lot of methods. I think we are going to look at 3 methods to do analysis. Right. Pressure is hydrostatic. Okay, of course. Sebelum ni kita, kita dapatkan apa-apa persamaan pun kita, kita, when we, for example, in this chapter, masa kita establish the conjugate depth equation kan, kita pun look at a control volume where we have hydrostatic pressure force, right, left and right, okay. So the assumption would be the pressure is hydrostatic lah, alright. And then resistance of flow, alright, at any depth can be assumed using uniform flow equation, that means Manning lah. So therefore, this is the resistance or the energy slope, right? Alright. And then okay, alright. Okay, now total energy of gradually varied flow in a channel of a small slope is given as this formula. Now, here's the thing. This is total energy. So they include the, the height of the bed of the channel with respect to a datum. This is datum, okay. Now, specific energy is just this part, which is y plus v squared over 2g. So you have specific energy. This is total energy. So I hope you are clear with it. Actually, we have learned this in our fluid mechanics lah, alright? But in pipe flow, you have pressure, right? Pressure flow instead of y lah, alright? Y you replace with pressure term, pressure heat. Now, okay, this is just it's actually the same equation, alright? It's just, if you look at the control section, right, you have, the elemental portion of it lah. You have dH over dx equals to dz over dx, alright? And so on, alright? So I'm just going to skip this lah, alright? Alright. Actually, what you come up to, if you go through all the equation, right, you are rearranging it, you'll get the dynamic equation of gradually varied flow. Don't worry about this. Actually, now what we are looking at is, okay, here's the thing, we want to analyze gradually varied flow. I'll just draw out a gradually varied flow, okay. This is the channel's bottom. Ini lantai channel kita, alright. Pada setiap titik ni lah, okay, oops, saya lukis sebab saya kata ini keratan kita, banyak keratan lah. Tak kisahlah keratan yang macam mana pun kan. Okay, maksudnya tak kisah the interval of the keratan, tak kisah. dy means, ini dx, dy means the difference here. Maknanya ada perubahan. Ini dy. dy. Kalau ini saya kata elemental 1, dy1 dengan dx1 lah. Kemudian berubah lagi. Kalau kita tengok elemental kedua, we have dx2. Alright. dx2. Now, it changed from y to another y, so you have delta y2. All right. So I hope you are clear. That means it's the changes lah. All right. So now, you know, the change in dy over dx is equal to s naught minus sf divided by 1 over q squared t over ga cubic power. All right. Okay. If you, this term is actually if you remember, this is when we analyze the critical flow, right? You have this term lah. All right. So now dy over dx equal to this lah. All right. Based on, when you differentiate this energy equation. All right. Now, you also have other forms of dynamic equation of gradually varied flow. Don't worry about this. I'll just put this up because when you do your further analysis or further study, you would like to know all this lah. All right. Okay. Actually, we are going to use all this equation. All right. It's just the various different equation lah. We are going to use it. I'm just going to introduce it. I'm going to skip this. All right. Another form of gradually varied flow dynamic equation would be this. All right. This one here, we look at the changes in specific energy with respect to the change in distance lah. All right. So it's just S naught minus SF. All right. Okay. So we have so many dynamic equation, if you look at here, but we are going to look at only three, which is the direct integration, numerical integration, and direct step. All right. The term is like repeating. You have direct integration, then numerical integration, then direct step. Okay. Now, why we want to use this? Why we want to do analysis of gradually varied flow profile? Actually, okay. When there is gradually varied flow profile, okay. For example, due to a structure downstream, then you have flow, backwater flow, right? We can actually determine how far this backwater flow would occur. I mean, the gradually varied flow profile would be. That means we can determine L, the distance, and we can actually determine also the depth of flow at any section. Well, here's the thing. Why we need numerical modeling? We actually have software, right, to model all this. Because we include all this formula in the subroutines of programming. They can actually help us calculate all this. That's why you can see simulation of flood and things like that, right? Because all these formula are in the computer, in the subroutine of a program already. So when you give, why not, YC, everything, they can help you, show the simulation in real time. However, we are going to learn the basic, all right, the governing equation before you do the simulation, basically. So all these are governing equation. We are going to calculate this manually, so you have a sense of how, the simulation, people do simulation and how they come to it lah. Okay. Now, so kita punya objektif, alright, untuk topik seterusnya ni, okay, ialah kita sebenarnya nak tentukan berapa jauh jarak gradually varied flow profile dengan ukur dalam dia pada sela tertentu lah. So you can, of course, we can know Y1, all this lah, right, the depth and also L. Okay, I'm not going to go through, but we are going to start on Sunday lah. The direct integration, all this. Actually, the slide has a lot of this because I actually recalculate this lah. That's why I put it here. I have Excel file lah that do all this calculation. I found out, well, if you look at this Wendy Chow, I think I shared this reference book with you in our author. You can download it. If you look at it, I think there's one mistake. I don't know which one because I recalculate everything. When I type it, I noticed that there's one error in that book. but I'm not sure lah which one is in the reference of that book, Wendy Chow book. Okay, this one also, I maybe next Sunday I'm not going to explain all this. I'm going to explain this today. It's just to go through it. Okay, you have this formula, direct integration. This is the formula that we are going to use. All right, so you have FUN, FVJ. How to find FUN and FVJ? We are going to use the same table, which is this one. So you can also use this table for FVJ. So we'll come back to this next Sunday. Don't worry. Okay. Now, how do you find J and M? Here's the formula. To get J, you need N and M. N and M depends on, it's a hydraulic exponent, which depends on the shape of your channel, the section of your channel. Now, how do you find V? Of course, once you get J and N, you can find V. U is Y over Y naught. All right. Now, let's get to M and N. How did we get M and N is coming from this formula. This formula here, I rewrote it for the shape of trapezoidal channel. I'm going to actually, I solve A, T, dt, dy lah. All right. In terms of trapezoidal channel, I'll get this formula. All right. And then for rectangular, of course, I can solve it directly lah. All right. And then you have all this. Either, okay, M and N is given to you. All right. Or either is given in this table here. You can find, for rectangular shape, M is one number, which is M, which is 3. If you look at this, right, this is rectangular. This is M. M is just 3. But for trapezoidal, depending on the side slope Z, if it's 0.5, you have to read it from here lah. Of course, this should be known first lah. You read it from here. All right. See if it's Z equals to 1, you are going to get your M lah, somewhere here. All right. This is circular. For circular, this is D naught. That means you are using this Y over D naught. For rectangular and trapezoidal, you are using Y over B to read the Y-axis value. Then you can read your M lah. Okay. Clear yang ni sebenarnya saya akan ulang lagi next Sunday. Saya just go through lah supaya next Sunday saya tak perlu ulang a few times. Same thing here. This is to find N. You have circular line. You have rectangular line. You also have Z. So it depends on Y over B. Yang ni semua dah ada. Alright. And also D naught is the diameter lah of the circular. Then you'll get your N. Actually, this one here, I have the Excel file lah. Yang kalau tengok, stop presenting. Alright. You can see my Excel file, right, everyone?
Yes.
Okay. So this is how I calculate, my data according to that formula that I've showed, the hydraulic exponent formula equation, right? So for various Z. Now, here's the thing. Look at this. Ini Z 0.5, Z1, Z1.5. Kalaulah saya tambah tengah-tengah, alright, for example, 0.7, it's okay. I have 0.75. That means, okay, wait now. I'll check first. What change? Wait now, I cannot do that. Okay, see. What else? Okay, should be okay. This one E. No, this should be here. Okay. Then you're going to have, okay. Oops. Okay, so if I'm going to plot another line lah, let's say, I'm going to add another line. Select data, I'm going to add Z. Z equal to 0.75. Okay. So X value would be, my X is M. M is this one here. And then my Y would be this guy here. All right. So, you see? So, what apa yang saya nak cakap lah, kalau lah you tak jumpa Y over BU. Maksud saya bukannya, kalau you tak, maksud saya kalau lah ZU, contohnya ZU tak diberi. Contohnya yang saya kira kat sini adalah 0.75. What you have to do is you have to sort of like interpolate lah between Z equal to 0.5 and Z equal to 1. So you have another, curve for Z equal to 0.75. Similarly for other lah, contohnya kalau ada soalan yang kata Z sama dengan 1.75, jadi you kena interpolate lah. Satu curve antara 1.5 dan 2. Ini contohnya. Alright, so I'm going to unshare this. Okay, now do you have any questions so far? Saya sebenarnya kalau tak ada soalan, kita akan start analyzing gradually varied flow profile next Sunday. Do you have any questions so far?
No. If they didn't give the values of 0.75, what we need to do? Like we need to.
Oh, you just sketch out the curve in between. In between Z equal to 0.5 and 1.
And the values?
When you sketch it out, you can you find Y over B first at the Y x-axis, then you draw a horizontal line, intersect with Z equals to 0.75, then you find your M value. M or N lah.
Okay.
Okay, it's okay, don't worry about it. I'm just, introducing all this. We are going to use it on Sunday. Boleh So that's why I want you to go back, before the class, go through the slide first. So it's easier for you to understand. Boleh semua?
Dekat exam ada ke doktor?
I'm sorry,
Dekat
Taiba?
exam ada ke? Exam. Final exam ada ke? Analysis
Final exam. Final exam, don't worry. Final exam normally will provide you the graph and you just read it from the graph.
Okay, doktor. Okay.
Saya
It's
sebenarnya,
complicated.
I just want you to understand how all this come about lah. Alright, okay, don't worry. Because nanti you go through your slide kan, you kata banyak sangat lah benda ni, semua kena faham ke tidak. Saya sebenarnya nak fahamkan, tapi hanya formula tertentu saja yang you perlu tahu lah. Dan formula tu sebenarnya we are giving it to you too, don't worry. All those formula we'll provide it. So kalau tak ada soalan, kita sambung Ahad depan
Okay, can doktor.
Alright, okay. Remember go through the slide then we'll do the analysis on Sunday. Take care semua.
Okay, I already download the slide already.
Alright. Okay.
Thank you, Doctor.
Thank you, Fatima. Alright, Ain.
Thank you, Doctor.
Alright. Okay.
Thank you,
Thank you, doktor.
Alright. Jumpa
Thank you,
Ahad
Doctor.
depan. Alright.
Thank you, Doctor.
Thank you, Doctor.
Alright.
Thank you, Doctor.
Okay.
Thank you, Doctor.
You're welcome.
How about the test, Doctor? You already mark, is it?
Oh, I can't find time to finish the marking yet. I'll let you know. Alright, Pri.
Thank you, Doctor.
Yeah, ask for the activity 4.3.
You want the activity 4.3? Wait, I'll check. Where is activity 4.3? You want to look at it? Is it, Jinseng?
Yeah.
Alright.
I want to ask the power due to energy loss.
Wait. 4.3. Okay, this one. I'm going to share the slide. Is this the one, Jinseng?
Yes.
Okay.
Can I ask for the V? Because the formula is rho G Q energy E.
Okay.
Ah,
Oh, you can express it in terms of energy or power over width.
oh,
Over meter. For example, this one percentage, right? I didn't solve the last part.
yes.
Okay, so the power, right? Power is in watt, right? Am I right? In
Yes.
watt, right? So you give your formula in watt over meter.
Okay.
All right?
Thank you, doctor.
All right. You're welcome.
Thank you, doctor.
You're
Thank you,
welcome.
Doctor.
Okay.
Thank you, Doctor.
Bye-bye.
The project,
Thank you, Doctor.
Project actually, saya lupa nak share. Saya bagi dalam group nanti. Boleh?
boleh, Doctor.
Alright.